Hello, welcome back to my channel. So I'm back again with another set of important questions. So without wasting any time, let's begin with the first questions. But be ready with your book and pen to note down the important questions and answers. Yes, here is your first question. So light travels faster in substance X to Y, then the refractive index is greater for. Okay, so here light travels faster in substance X as compared to Y. So how speed and refractive index is related? Yes, so we know that refractive index of a medium is inversely proportional to speed of light. So since the speed of light in X is greater than speed of light in Y, then the refractive index of X will be less than refractive index of Y. So what is the right answer? Then the refractive index is greater for substance Y. Yes. So you just have to remember this relation. Refractive index is inversely proportional to V. So let's move to the second question. Yes. The speed of light in glass is 1.5 into 10 power 8 meter per second. Then refractive index of glass is. So speed of glass is given, that is 1.5 into 10 power 8 meter per second. Now we have the formula N equal to C by V. So we know that C is speed of light in air or vacuum. So that is 3 into 10 power 8. And here this is 1.5 into 10 power 8. So instead of writing 1.5, you can write in fraction. So it will be 3 into 10 power 8 divided by 3 by 2 into 10 power 8. 3 by 2. So 3 and 3 will get cancelled. 10 power 8, 10 power will get cancelled. So remaining will be 2. So option is D. So next question. An object is placed at a distance of 30 cm from the reflecting surface of a concave mirror of radius of curvature 40. The image formed is. So here radius of curvature is given as 40 cm. So as per sign convention, minus 40 cm. So focal length will be, yes, r by 2, that is minus 20 cm. Now it is given the object is placed at 30 cm. So object distance is minus 30 cm. So if focal length is 20, so your focus will be from the mirror. Yes, focus will be 20 cm and center of curvature will be 40 cm. This is C, which is 40 cm from the mirror. So object is placed 30 centimeters. So it is between F and C. So object is between here. So when object is placed between C and F, where will you get the image? Absolutely, you will get the image beyond C. So beyond C, what is the nature of the image? It will be real and inverted, and it will be magnified, or we can say enlarged. So what is the option? Virtual magnified, virtual diminished, real magnified. So option C. So here is your next question. Mirror X is used to concentrate sunlight in solar furnace, and mirror Y is fitted on the side of the vehicle to see the traffic behind the driver. So which of the following statements are true for two mirrors? Okay, so X is used to concentrate sunlight in solar furnace. So what type of mirror is X? Very good. Mirror X is concave. Now, then what about mirror Y? Mirror Y is fitted on the side of the vehicle to see the traffic behind the driver. So mirror Y is convex. Which of the following statements are true for the two mirrors? Okay, so the first option is the mirror formed by X is real, diminished and at its focus. Okay, so here in the question it says that it concentrates sunlight in solar furnace. So sun is at infinity, so image will be formed at focus. So this option is right. Now mirror, the image formed by mirror Y is virtual, diminished and erect. Yes, it is a convex mirror which will always forms erect and virtual and diminished images. So this is also true. Now the image formed by X is virtual, diminished and erect. No, because we already found that it is real and diminished. So this is wrong. Now the image formed by Y is real, diminished and at its focus. No, because we already found it as virtual. So the only option is 1 and 2. So option A. Yes. In the following cases, a ray is incident on a concave mirror, in which case angle of incidence is equal to 0. Yes, let's see. A ray parallel to principal axis. So what happens to the ray parallel to principal axis? Very good. It will pass through focus. Now a ray passing through center of curvature and incident obliquely. So if a ray is passing through a concave mirror at point C, if it is passing through C, what happens to the light ray? Yes, it will reflects back along the same path. Why it reflects back along the same path? Because the incident ray hits the mirror perpendicularly. In that case, angle of incidence is 0. So what is the right option here? Option B. What about C? A ray passing through the principal focus and incident obliquely. So what happens to the ray passing through principal focus? Very good. It becomes parallel to the principal axis after reflection. Now what about the ray incident obliquely to the principal axis at the pole? What happens if it hits at the pole of the mirror? Yes, it will reflect obliquely by making same angle of incidence and reflection. So the only option that gives angle of incidence 0 is when it is passing through the center of curvature. So let's move to the next question. Yes. So the refractive index of 3 media are given below. Okay, A, B, C, 3 media are given and the refractive index is also given. A ray of light is traveling from A to B. So A is 1.6, B is 1.8. Okay, and another ray is traveling from B to C. So B is 1.8 and C is 1.5. In which of the two cases the refracted ray bends towards the normal and why? So these are the two cases given. Light rays passing from A to B and B to C. So in which case do you think the light ray will bend towards the normal? So what do you think? Absolutely. From A to B, light ray will bend, yes, towards the normal. Towards the normal. Why it bends towards the normal? Very good, because light is passing from optically rarer to optically denser. So what is the reason? That is the question. So first we have identified that light ray passing from A to B will bend towards the normal. Now we have to give justification why. Why? Because A is optically rarer, B is optically denser. So if a ray of light passing from optically rarer to optically denser, it will always bend towards the normal. In which case does the speed of light increases in the second medium? So again, A to B, B to C. In which case do you think the speed of light will increase? So here light is entering from A to B. Here light is entering from B to C. So in the second medium, which one do you think the speed of light is more? So here second medium is B. Here second medium is C. So in which case the speed of light increases? From A to B or from B to C? Absolutely. The answer is B to C. Why? What is the reason? Very good. B is optically denser, C is optically rarer. So when light ray passes from optically denser to optically rarer, the light ray bends away from the normal, which means that speed of light is more. So let's move to the next question. Yes. A ray of light is incident on a glass slab as shown in the figure. Okay, so light rays entering from air to glass through the path of refracted ray in the block and refracted ray in the air after passing through the block. So you have to complete the ray diagram. So air to glass, what happens to the light ray? Yes, it bends towards the normal because optically rarer to optically denser. Now you have to draw the normal here. Yes, now the light ray is coming back to air from glass. So again, optically denser to optically rarer, it will bend away from the normal. So this is the diagram. Now label lateral shift, refracted ray, emergent ray on your diagram and state any one factor that affects the lateral shift. So here you have to label the lateral shift. So in order to label the lateral shift, you have to extend your incident ray. Yes. So lateral shift is the, what do you mean by lateral shift? Yes, this is lateral shift. Okay, I am marking it as A. So here A is the lateral shift. So what do you mean by lateral shift? It is the perpendicular distance. Yes, perpendicular distance between the actual path of the incident ray and the emergent ray. Now you have to label refracted ray. So which one shows the refracted ray here? Yes, this is your refracted ray. This is refracted ray and your emergent ray is this one. So this is your emergent ray. So draw the diagram neatly in your notebook and label all the points. Okay, you have to label lateral shift, refracted ray and emergent ray, and also you have to state any one factor that affects lateral shift. So we have learned many factors that affects the lateral shift. So what are the factors? The first one is angle of incidence. So how is it related to lateral shift? Yes, angle of incidence is directly proportional to lateral shift. So if angle of incidence increases, lateral shift also increases. Second one, refractive index. Refractive index of the medium. That is, here the medium is glass. How is it related? Refractive index of the medium is, yes, directly proportional to lateral shift. So if refractive index is more, then the bending of light is more towards the normal, which will increase the shift. Now third one is thickness of the slab. Thickness of the slab. Okay, so these are the factors that affects the lateral shift. So how thickness is related to lateral shift? Yes, thickness is directly proportional. Thickness is directly proportional to lateral shift. So more the thickness, more will be the lateral shift. Yes, let's move to the next question. Yeah. So the focal length of the concave mirror is given, that is 15 centimeter. An object is placed at 10 centimeter from the mirror. Now what will be the sign of image distance according to new Cartesian sign convention? Justify your answer. So here focal length is 15, so minus 15. Since it is a concave mirror, sign is minus. And object is 10 centimeter, so it will be minus 10 because it will be on the left side. Now we have to find the sign of image distance. So tell me, what would be the sign of image distance? Pause the video, think about it and comment. Absolutely. The sign of image distance will be positive. Why it is positive? Yes, because object is placed within the focus. Here focal length is 15, but object distance is less than 15 centimeter, which means that it is between F and P. So if object is placed between F and P, where will you get the image? behind the mirror. Image is formed behind the mirror. Since it is formed behind the mirror, it will be virtual and erect. Okay, behind the mirror means right side of the mirror. So distance measured to the right is taken as positive. So as per sign convention, the image distance sign is positive. Now state the nature and size of the image formed if the object is now moved to 30 cm from the mirror. So what will be the nature and size of the image if object is moved 30 cm from the mirror? Yes, initially it is given that focal length is 15 cm. So 30 cm means where is the object placed now? Absolutely. Object is placed at C. Object at C. Okay, this is the answer for the second one. Object is at C. So what will be the nature and size at C? Yes, it will be real and inverted. Real and inverted. And what about the size of the image? Yes, same size. Size of the image is same. Now let's move to the next question. Study the figure in which the path of the light ray going from medium 1 to 2 is shown. So out of the two media, that is medium 1 and medium 2, in which is the speed of light is more. So here diagram is given, so you can see that the light is moving away from the normal when it enters medium 2. So if it moves away from the normal, what does it mean? Yes, the light is entering from optically denser to optically rarer. So what about the refractive index in rarer medium? Refractive index is less. Refractive index is less. So if refractive index is less, what about the speed? Speed will be more. Why? Because n is inversely proportional to v. So in which medium speed of light is more? In medium 2. Okay, in medium 2, because light ray is moving away from the normal, which means that the refractive index is less. Lesser the refractive index, more the speed. Yes, state the reason of bending of the refracted ray away from the normal. We already stated, because refractive index is inversely proportional to speed of light. As the ray is moving away from the normal, it means that the refractive index of that medium is less. So lesser the refractive index, more is the speed of light. Now express refractive index of medium 2 with respect to medium 1 in terms of speed of light in both the medias. Okay, so let speed in medium 1 is V1, speed in medium 2 is V2. So how can you express in terms of speed? Yes, refractive index of 2 with respect to 1 is equal to N2 by N1, which is equal to V1 by V2. Why? Because both are inversely related. That is why we are writing V1 by V2. So this is the answer for the third one. Okay. Yes. So let's move to the next question. So the figure shows the ray of light as it travels from medium A to medium B. Yes. So in this case, light is traveling from, see the arrow. Okay. A to B. Calculate the refractive index of medium B relative to A. So we have to find the refractive index of B with respect to A. So here they have given the angles. So you have to use sine I by sine R, which is equal to NBA. Why we are writing NBA? Because the refractive index of medium, N means refractive index of medium. So here the light is bending in medium B. That is why we are writing NBA. If light is bending in medium A, we write NAB. Okay. So in this case, light is traveling from A to B and bending occurs in B. So we write NBA. So what is the angle of incidence in this case? Yes, angle of incidence is this. Angle between incident ray and the normal. So sine 60 by sine R. R is angle of refraction. This is your refracted ray. So this is the angle of refraction. So sine 45. So sine 60 is, yes, root 3 by 2. What is sine 45? 1 by root 2. So you can take it to the numerator. So root 3 by 2 into root 2. So this can be written as root 2 into root 2. Okay. So you can cancel out this root 2 and this root 2. So finally you will get root of 3 by 2. Okay, so this is your final answer. Now connect the refractive index of medium and speed of light. So how can you write in terms of speed of light? Yes, NBA, which is equal to NB by NA, that is equal to VA by VB. This is the answer for B. Okay, this is the answer for A. This is B. Now C. Can a ray of light travel undeviated when it passes into the second medium? If yes, give a condition. So is it possible for the ray to just pass through without any deviation? Yes, it is possible. So what is the condition? Refractive index of both medias must be same. Yes, refractive index of both media must be same. In that case, the light ray will just pass through without any deviation. Now D. Refractive index of diamond with respect to glass. Okay. D is refractive index of diamond with respect to glass is given as 1.6 and the absolute refractive index of glass is 1.5. That means NG is 1.5. Now you have to find out the refractive index of diamond. So we can write NDG, which is equal to ND by NG. So NDG is given, that is 1.6. ND we have to find. NG is also given, that is 1.5. So ND is equal to 1.6 into 1.5. So when you multiply these two, you will get 2.4. So that is the refractive index of diamond. Okay, so I hope this is clear to you. So go through the questions carefully one more time and try to solve it by yourself. So you can post any doubts on the comment box. I'm always here to help you. So that's it for today. We will meet again with another interesting topic in physics. Till then, bye.